what is exactly aging is all about. So when it comes to that word aging, this represents a gradual decline. This represents a gradual decline in physiological functions. When body's capability to perform physiological processes goes down in a very gradual manner, this is what is called as aging, guys. There is a gradual decline in physiological functions. In order to study aging, we can able to go into the depths of aging in two different dimensions. Number one, everything related to the cellular processes. What happens at cellular level so that someone gets aged? So irrespective of their birthday, irrespective of their chronological time, some people start showing symptoms and signs of old aging at quite a young age itself, and there are obvious and there are proven cellular changes we can able to see, document from those subjects. Alright, so there are actual cellular processes that if they happens, obviously it indicates old age. Alright, irrespective of their actual age or something, it just indicates that they are turning old. And on the other side, system processes. What are all the changes that see in organ system levels? What are all the changes happening in cardiovascular system? What are the changes happening in neurological functions? So that is how we can able to study aging in two different aspects. Alright. So number one, it is going to be cellular processes, and number two, it is going to be system processes, guys. Let's start with cellular processes. Now when it comes to cellular processes, the first and foremost point you have to know about aging is about a segment in chromosomes called as telomeres. Segment in chromosomes called as telomeres, guys. To make you understand, consider this as a parent cell. Alright, let this be one parent cell, and in this parent cell, let me just take up a chromosome. Alright, consider this as a chromosome here. So yeah, I'll give you a different color so that you can able to understand this. Consider this as a chromosome. In this chromosome, at the tail of chromosome, you are going to find a structure, and this structure is what is called as telomeres. It is what is called as telomeres. When this parent cell divides into two daughter cells, when this cell goes for cellular division, right, there is obviously going to be chromosomal separation, and these parent chromosome turns into daughter chromosomes, and they again goes for replication, all those processes. So consider these chromosomes as daughter chromosomes. If you compare the sizes, the chromosomes retain their size, but the length of telomeres have actually decreased. Telomeres was not very lengthy, telomeres have actually decreased in size. So what was a lengthier telomere at the parent cell? As the division takes place, the size of telomeres keeps getting decreasing and decreasing and decreasing. At one point, when the telomeres have been extincted, when there is no more telomeres available in a chromosome, that is the time where cell division stops. Alright, that is the time where cell division stops, people. So the whole process of cell division is dependent on length of telomeres. Length of telomeres is directly related to cellular replication or cell division. When it comes to cellular replication or cell division, people please remember, this cellular replication or cell division is essential for growth. Number one, if an organ has to grow or if a muscle has to grow, the cell has to multiply. That is absolutely needed. Alright, number one. So when telomeres stops, when there is no more telomere available, cell division stops, which means there is not going to be any further growth. When growth ends, aging begins. As simple as that. Alright, number one is going to be cellular replication, which is concerned with growth. Number two, it is going to be repair mechanism. Imagine I have a tissue, but this tissue is getting subjugated to repeated stress and strain. I'll give you an example. Now I have a patient who is a weightlifter, who is a porter in a railway station, and his job is to carry huge loads of trunks, huge sacks of grains and everything on his head and muscles and everything. So with repeated exposure to stress and pressure and everything, there is going to be wear and tear. The muscles are going to gradually lose its capability to multiply and grow. So with the pressure induced damage, with one muscle cell dying and another muscle cell dying, he has to develop a new muscle cell. So in order to replace the dead cells, he has to develop new cells. How long can he able to do it? As long as the telomers supports his multiplication. So as long as the telomers supports his multiplication, he can able to do this. But once this point is reached, alright, at a point where the telomeres have extremely shortened and there cannot be any further replication, at that point there is going to be failure of repair mechanism as well. So when repair mechanism fails, that's it people. There is not going to be any further growth, there is not going to be any further repair, and from that process onwards there is going to be cellular damage, and cellular damage is nothing but aging. So number one, it is all and all about telomeres. Alright, and let us take up the second important point.